Hello. Uh, Welcome everyone to this fourth installment of the series of sessions on 4 dimensions of DevOps. Today's topic is about release management and continuous integration. If you've watched our previous sessions, it covered a couple of other dimensions. We have one more dimension to discuss, which will be taken in our next sessions. This is Sridhar. I'm a senior software engineering consultant. I work for a company named Aspire Systems, which is proud to present this webinar. Before we start, I'd like to take you through a brief intro of Aspire Systems. We are more than 2,600 employees with 150 plus active customers. We are primarily focused on product engineering. So we specialize in building products, getting them to an MVP stage and beyond. We have expertise on software engineering, digital services, testing and infrastructure for application support. We have a global presence. Specifically, we have offices in Singapore, US, UK, the Benelux region, Middle East, and the development center, most of them are in India. We have CMMI level 3 certifications and ISO 27001 certification. And we've won the Great Places to Work Institute's Best Place to Work Award 9 consecutive times. That I think gives you a pretty good idea of what Aspire Systems is. Moving forward, let's quickly look at today's agenda. The first few minutes we'll spend a little time to understand and go over a quick recap of what is templated approach, what has been discussed so far. And after that, we look at release management and how we apply the templated approach to release management. So going over what a templated approach is, if you've seen our previous sessions, we are going over an exercise where we are trying to categorize the DevOps operation, the entire spectrum of DevOps into 4 different dimensions, with each dimension affected by certain parameters. And what we see here is a standard set of parameters, or rather a standard grouping of parameters, to simplify our selection process, to simplify our approach to solving or coming up with a plan for our development operations. So moving forward, as you can see, our 4 different dimensions, as we've seen over with our experience working with customers across the globe in different business domains, as well as at different stages of development. Typically, what we see as these dimensions are infrastructure management and automation, release management and continuous integration, continuous testing, and underlying it all, the 4th dimension is orchestration, monitoring, and the feedback loop. The reason that we split this whole thing into dimensions is because each of these dimensions can be addressed as a single unit without it affecting the other dimension, so that we have a clear-cut goal of solving a problem in that dimension. Of course, there can be exercises that cuts across all dimensions, but it still has to be looked at in a separate silo. And these are our silos. So these 4 dimensions are basically what we've found to be true. Of course, there could be possible debates on testing being a part of development operations, but in most of our cases, yes, we've seen testing to be very much a part of the whole development operations cycle. In fact, it becomes a very crucial part. Testing controls the whole operation in most cases. And quickly moving forward to parameters. So based on our experience, again, we've understood and identified 5 different categories of parameters. The first one being distribution. That is, how distributed is your team? How distributed is your product? How distributed are your customers? Distribution, not just geographically, technology-wise, in the sense how many different technology stacks do you use? How widely spread in the spectrum are you? So distribution talks about the variety that a company or an organization has in its offering. Technology, of course, it is an important aspect. The technical stack determines a lot of things, and so that is one of our major parameters. The scale and load. Obviously, performance criteria make for another important parameter. Every aspect of performance, the scale that it is expected to go up to or down to, and the load that is expected during peak time or off time, or whatever it is. So these together, the performance parameters make one group. The fourth parameter that we've identified is environments and security. How are environments defined? How is the security model? Are these environments close to outsiders, or are these environments very open, or is it closed at some places and open at some places? Is it a hybrid model? Is it a completely cloud deployed model? So all of these will be dealt with in the environments and security parameters. And finally, your release parameters. To say, is it a product? Is it should it be deployed, or should it be packaged and given as a download? The frequency of releases. How is it a nightly build? Is it a monthly build or a weekly build? How frequent do you roll out your changes, or how frequently do you ask your customers to pull in changes? So all of these parameters come under release. Moving forward, so what we are trying to achieve with the templated approaches, we apply these parameters across all 4 dimensions and identify the things that are necessary or that fall under that particular parameter, identify conditions and criteria that can help us determine or find out or templatize an approach to plan our development operations as a whole. But again, you take it in parts, in dimensions. So having looked at what the templated approach is, we'll move on to today's topic, which is release management as such. What is release management? I mean, it is definitely something that's important to every organization. Every organization wants things released and out of, sent to their customers, sold to their customers as soon as possible with the best quality as possible and all that. So what is management of a release? So modularization of deliverables, that is, how modular is it? How do you manage to integrate all of them? How do you manage to package it? How do you sell it in different packages? What are the combinations or variations of the packages? How many stages of releases do you have? And what are your versioning policies? What is version management as such? Dealing with backward compatibility. And all of this together forms release management. And of course, you deal with the question of when it comes to release planning. When do you want to release it? How periodically do you want to release it? When do you certify something as production ready? And who provides that certificate? And what is the rollout plan? So all of these planning aspects come into the question of when. And how? That is, how many geographies do you release it into? What is the scale? How many machines? How many instances? How many clusters? How many regions? And all these security-related concerns. Which of these services should be open? Which of these should be closed? How do you handle security? How do you prevent all of these hacks? What is the archival strategy? Clean up of your systems, clean up of your code, clean up of everything. everything in the cycle, cleanup of VMs, any unused resource, and upgrade planning, scheduling, rollback. So we are attempting to look at all of these aspects of release management in a nutshell and trying to arrive at a template today. So moving forward, let's look at one very frequently asked question. Continuous integration or deployment or continuous testing has sort of become the buzzword now that everybody wants it in their development or development operations pipeline. One basic thing that I would like to put forth is the whole continuous operations thing is not for everyone, is what we've seen, right? Continuous integration requires, it involves a lot of cost, and it requires a kind of discipline from every participant, and it needs that confidence in the setup, and it needs constant feedback from the system and members. It needs to be improved. Ultimately, all of these processes are supposed to help your team, not make it worse for them. So if and when you choose to do this continuous integration, deployment, or testing, make it a point to evaluate your return on investment at every step. If it is making it difficult for even one person in the whole system, then make sure that you do a proper analysis and ensure that your return on investment is better than before. Right. So when would you do continuous integration or all of these continuous processes? Right. Typically, we've seen that continuous integration or deployment or testing, it is required when your delivery cycles are very narrow, when you have a very unforgiving sprint where every release is important and these releases are timed in a very quick succession. It becomes very important that with this setup, your developers get as much time, and so all of these other steps, other manual processes that are not important to a developer per se, but it's important to the release management aspect as such, can be automated. So in that sense, the whole continuous integration, deployment, testing aspects become important. Similarly, if there are multiple points of failures built into your delivery stream, suppose there are multiple modules each being developed separately, and the integration testing needs to be done before release, and there are multiple points of integration between your modules. This makes it a prime criteria for CI/CD. The integration testing is the primary aspect here. This is what makes it applicable, and this can also be done when the teams are distributed. If the teams are sitting geographically in distributed locations, or it can also be functional distribution per se. Say your development team wants to hand over a release to a testing team, and within your testing team you could have multiple teams, again, one for regression testing, one for performance testing, one for new functionality testing, or whatever it is. So if your pipeline has to go through several teams that are geographically or functionally distributed, then it again makes sense. So CI/CD is definitely applicable in these cases. In any other case, I'm not saying it is not entirely pointless, but please make sure to ensure that you measure your return on investment and make sure that you're getting better return on investment than before. Moving forward, so today's goal is to come up with an idea to create a template based on these parameters on the release planning dimension. Right. So with respect to release planning, the parameters that affect, we've seen the broad category of parameters, but let's drill down a little bit into what these parameters are in terms of release planning. Right. In terms of distribution, as I've said, we have to know geographical distribution. We have to know operational or functional distribution, the number of levels or stages, the number of environments that it skips to. So distribution in a lot of terms. Any variety in your product is to be accommodated here. So there are even multiple stacks of technology. All of that needs to be accommodated here. Second parameter is scale and load. The count of deliverables, modules, the products, their number of instances, the number of clusters, expected performance numbers, response times, or all of those standard performance parameters. Right? So those will come under here. Assuming all of this is for the typical software product, maybe a typical service-based web application which has multiple services underneath it that are exposed only to certain consumers and not to everyone. Again, there could be several identity and access management solutions here. The third parameter, as you see, is environments and security. The network level security, what are the differences between environments? That is, you could have a development environment, a testing environment, or a production environment. What is the difference between this? How do you make sure that your production environment is as stable? How do you make sure you test it in a production-like environment? What are the rollback mechanisms in the worst case of a failure? So all of these come under environments and security. Cost, cloud versus in-house or hybrid, and all your retention policies. Not just the cost, cost along with your, it's not just monetary cost, it's also time that is to be considered here. So how long you spend, how long your development team waits is still cost to you. So cost in terms of time and money. Release is another parameter which we've already talked about. How periodic do you want releases? Is it a nightly build, a weekly build, or a monthly build, or a yearly build? And what is upgrade management? What is the plan for upgrades? How frequently do you upgrade? Where do you manage your deltas between versions? What is the backward compatibility strategy? Do you just upgrade things and let services connect to you even though they're newer? So all of these are in detail parameters that are again classified into the 5 dot topics. Moving forward, so our goal is to come up with a template that has a list of tools that we can possibly use, a list of processes that we can again possibly use, and a list of control mechanisms that we should be looking at. So for that, let's first look at the master set of tools, again broadly classified into enterprise class applications, open source applications, completely outsourced PaaS solutions, and certain other tools that help with containers specifically. So as you can see, there are plenty of tools. I'm pretty sure I would have missed a few here. It still doesn't matter. There are, again, a lot of tools. A lot of new tools are coming up every day. So it's still, it makes it pointless to make an exhaustive list here. But what we are doing is we are trying to accommodate every new tool that we see with our experience. We look at it, we do a proof of concept on it, or we try to understand it, and then bring it into our templated approach. So the tools that are listed here are basically this is our set of list. This is our experience basically. We've worked on all of these tools. We have a dedicated team that works on all of these tools. Every tool has its own expert within our organization. So with these set of tools, again, the classification is important here. Like as I mentioned before, every category has its own cost of setup and cost of maintenance. So that cost of setup and maintenance is what is important. We'll have to realize and understand how it affects our return on investment. For example, most of these enterprise release automation tools are quite expensive, but they are also the best in terms of support. There is always someone dedicated for you to help and support you. In terms of the open source tools, yes, there are plenty of them, and for some of these tools, there are also a very active, there is probably almost everything here is an active community support. There are a lot of people who can answer and help. There are a lot of people who have faced problems and have solved them and have posted the solution online. So I'm not essentially saying open source is bad for an organization. In fact, most of the projects that we've done, we've had to adopt open source tools to keep costs down. And in no way are these open source tools any less effective than the enterprise release tools. Just that you may have to do a little extra work to get them working for you. But it's still, if it saves on your returns, which is good. And in some cases, we've just had to offload all of that work to a PaaS provider. So all we do is check in, and the PaaS platform takes up your code, deploys, and runs it immediately. So, which can be a neat solution if you don't have the expertise of setting things up. So I've seen a lot of people go the PaaS route as well. So having looked at the list of tools, let's go look at the master list of processes that we want to look at. So as you can see, we have continuous deployment, continuous testing, continuous integration, infrastructure as code. I'll get to that in a minute. Then PaaS-based delivery, which is what we just talked about. Monitoring of missions, incident management or escalation hierarchy, and failure or fallback processes. In all of these cases, this is basically a master list of processes, and to give you a brief of what we mean by these. We've already looked at continuous deployment. Basically, you want to deploy as soon as there is a change in your code or product or a component or a module, right? And make sure that it works fine. Continuous testing. So when there's a change, again, you make sure that you test it against your standard set of regression tests. Make sure that your product adheres to all your functional requirements and nothing is broken. With continuous integration, it's again, if you have multiple components, you want to make sure that they integrate and sit well together. Make sure that every change is tested in terms of deployment, in terms of regression, in terms of integration and coordination. Right. So those are the three basic topics, or rather more popular topics. Infrastructure as code it's become a trend that infrastructure is maintained as code rather than actual images or anything else, right? Today, with all cloud providers supporting some form of infrastructure as code, things have become a lot easier. You don't have to maintain images or templates or anything. You just have a JSON file that says how your infrastructure needs to be. Give that JSON file to the cloud provider, and you get the infrastructure as you need it. So that's become a very popular process these days. It's not expensive. It's quite cheap, and I would recommend everybody to start using it. The fifth, PaaS-based delivery is, again, makes life simpler for a company, for an organization. So again, it has costs associated to it. So evaluation of a PaaS product has to be done very diligently. The review of the products, of the platform's abilities, to ensure that it supports your current technology stack as well as what you plan in the future. So you shouldn't end up with a platform that can only do the work halfway through. You shouldn't be doing the rest yourself or giving it to someone else. Make sure that the platform that you choose is able to deliver everything that you need. Monitoring of everything, monitoring of your performance in terms of delivery, your check-ins, your development quality, your VM monitoring, your performance monitoring, and all of that will come into this. It's sort of a very broad category, but it's still important. Every aspect needs to be monitored. Every aspect needs statistics to come out of it. So how many check-ins go in per day, and how many reviews happen per day, and how many defects are logged per day. All of this can give you a decent amount of statistics. I mean, a decent amount of ideas to at least know what to fix in your pipeline, the entire pipeline. I mean, data needs to come in from every stage, not just development. Should come from testing, should come from deployment. Why are deployments failing? Why are your servers not withstanding your load and all that? So monitoring is an important aspect. It is a very broad process to be, we've sort of written it off here as monitoring, but it is somewhat broad, and there are multiple sub-processes involved within here, but it still can be categorized as one small thing, one chunk. Similarly, incident management and escalation hierarchy, there are several processes again within it. In a pipeline, it is your responsibility to choose how you handle incidents. You need to declare or decide and define processes that tells developers or every participant on how to handle a particular incident. What happens if a check-in fails? What happens if a test fails? What happens if a deployment fails? Or what happens if a production bug? So this is a set of processes depending on the number of stages you have, the number of people involved, every component in your development operations, right, till your production. So this is an important process that needs to be declared, defined, and refined at every stage. And finally, failure and fallback processes. As is usual, failure is not something that we can completely avoid. So it is, something is bound to fail at some time. And when that happens, we definitely should have a fallback process. We should know how to roll back things. We should know how to get things back to working condition, and we should know how to fix them. So that process, the level of severity, the SLAs for it, all of those need to be defined. So all of these processes together should be defined when you're defining a development operation process. Moving forward, finally, the list of control mechanisms, right? So what you see here is just a very crude display of how things could possibly be. You could have multiple pipelines for multiple components, and all these eventually combine into an integration pipeline and finally is released, right? So assuming the simplest scenario, we should look at these 5 control mechanisms. That is, we have to know the number of pipelines. We have to know the pipeline merges. We have to know when a pipeline should merge. It may not be necessary that 2 components that never interact in real time in production or anywhere. We shouldn't need an integration pipeline for these 2 components, right? But that's what these decisions have to be made right at the beginning. We have to know what component interacts with what other component and make sure that the integration of those 2 components is valid and important. Similarly, in this case, it is just 2 components, but you could have a whole maze of components. Every component may require its own pipeline. Some components may not even need a pipeline. Some components can just start working as is. Say, for example, if it's a very simple UI project and most of your other offering is just a service, it may not need a pipeline of its own. And the UI as such does not, if it's it's not working with the other services, it makes no sense. So make sure that every pipeline that you are running is necessary. Every piece in the puzzle is important, and run the whole pipeline only if it is important. Otherwise, let's not waste things. We have to be very mindful of pipeline merges. So here, as you can see, component 1 and the component N merges into an integration pipeline. This is possible in multiple cases or other multiple situations or multiple combinations of your components can be possible, and all of these need to be tested separately, and finally all of your components together need to be tested in one final integration suite. This can again depend on your offering, the way that you package your product, the way that you release your product, the way that that are modularized when you sell your product. So be mindful of the wastage here when you decide the whole workflow. The third aspect is approvals and workflow. You have to be sure that things move to the next stage only on success criteria, only on approvals, only if someone says that it can be a manual approval or a condition-based approval, which can again be controlled by a workflow. You can define these rules somewhere in your system, can be controlled by even whatever the control software that you use. It can be Jenkins or anything else. So you should be careful to define these workflows, define the approval process. You need to know who approves, when the approval happens, and when is something not approved or cancelled or reverted back. Right. And the fourth important point is failure management and escalation hierarchy. So as we discussed before, failure management is important. So it is possible that failure can happen at any stage in this whole maze of flows or maze of transactions, right? So it can fail as soon as someone commits things and your Maven build or unit test fails. It can fail during deployment, or it can fail during testing, or it can fail anytime during the integration pipeline. So when it fails, you need to have a control mechanism to say where or what happens, who decides on what happens, and what does someone allow it even though it has failed at some point, or should that component be ignored and still the product be released? So these rules and setup have to be again maintained and managed. And finally, the success or failure conditions, like what we were talking about earlier with workflows. The system, if it's automated, the system needs to know what are the failure or success conditions. When is a component successfully built? When is a component allowed to move into an integration pipeline? When is a component successful, or when has a component failed to pass certain quality criteria, right? So all of these criteria need to be defined somewhere. It can be very easy zero tolerance numbers, or it can be if it's sort of a daily release setup, or if it's a nightly release setup where it's okay to release buggy product at that point. Then for these kind of releases, you may want to reduce your, you don't want to stick to a zero tolerance policy. You will keep just releasing what you have, even though there are bugs, as long as it builds and deploys, even though testing may fail, or if there is new functionality that breaks a lot of things, it's still fine. But for a production release, for an actual stable release, yeah, you will have to manage and maintain the right success or failure conditions. So these set of 5 points give you a guideline to decide on your control mechanisms. Moving forward, so what we've done is we've looked at a set of tools that are possible in a typical development operations, a set of processes that one has to be aware of, set of control mechanisms, and to be to be more precise, what we are doing from our standpoint is that we are developing a tool that incorporates all of these ideas, incorporate all of our learnings into rules. And with these rules, we basically apply an elimination approach to filter our master list into a smaller list that's easy for us to at least evaluate. And then we narrow down on the master list with certain conditions. So with very specific conditions, maybe because of technology stack limitations or cost limitations or whatever. So elimination at the easiest level is done first, and then we apply a narrowing down policy, apply certain rules to eliminate even more rules, processes, and control mechanisms, and eventually come up with a finite list of things. So we are building this tool as we speak, and we also intend to keep it updated. We want to keep it updated as we go with experiences that we get from implementing it for our customers. So that's where we are, and this presentation is more or less presenting that idea and applying it for release management and in this particular case. So in summary, what we've actually looked at is how to apply the elimination approach to arrive at a set of tools, apply rules to narrow down on the set of processes, a validation process to narrow down on the selection and validation section, and validate the selections. I know that I've not taken you through an exact use case, but what we've done is presented the approach to our solution. This is more or less what we do as consultants. We apply this, we come up with a finite list, and although this is our guideline, we always look at it from a very, in the sense, as consultants, we don't want our jobs taken away by a rules engine, right? So we always apply our own experience, we apply our own knowledge on it, and validate it, evaluate it with our customers, and finally come up with a solution. So that's about it. Thanks for listening, and we can take questions now. And I see a nice question. The question reads as, in most cases, these templates or templated approaches never work. How do you propose that your template will work? To be very frank, I'm not claiming that my template or our template will work. What my claim is that the template that we produce, the result that we come up with, can be used as a guideline. It can, I mean, it's not necessary that it works for everybody, but it is something to start with. It is your base set of ideas. We can give you reasons why something was chosen and why something was eliminated. And it is possible that our template could have missed or could not even have considered a totally new tool. But it still gives you the reasoning, gives you the entire methodology so that you can try and apply it for all things that we've also missed and get back to a finite list that you can actually use. So what I'm saying is the template is not essentially your final recommendation. The template is more or less a guideline for you to start with. And no solution is ever complete without a feedback loop. Of course, whatever you implement, you have to keep reviewing it, looking at things, review it, keep improving it as you go. Right. So that's how things are. Thanks for the question. And I'll wait for a few more minutes to hear more questions. If not, then that's pretty much it for today. And of course, if there are questions after the session, you can always write to our support email or help email. Our number should be listed in this presentation somewhere. So you can always get back. Thanks.